Alright, and just put, you can put 212 just way up there. So then I'm going to connect these with a smooth curve. I'm going to make sure that that does not dip below the x-axis. Do you remember what we called this from yesterday? You can look back. Very good. Okay. Now what we're going to do is we were not given an equation to graph, we were just given the points. And sometimes it's hard to tell exactly what kind is which. So I'm going to show you how you can do that with the point. So we're going to do -2, 0.75. We're going to just list the ordered pairs and see if we notice anything. Okay, Jackie notices something. What do you notice?
It's doubling.
So if I asked you, yeah, what's the relationship between the y values? She says they're doubling. Okay, so in math, when we do that, when we figure out what's happening between the numbers and we're seeing what it's multiplied by, we call it it's not squaring, it's multiplying by 2 over and over and over, which is why it's exponential. It's actually doing this. It's doing 2 once and then 2 twice, and okay. We're not going to, later on in the year, we're going to learn how to make exponential equations, but just for now, we should be able to see that if these are being multiplied to get to the next thing, they're exponential. And actually, another way of looking at it,
It's supposed to be 1.5, not 1.6.
well, what in the world? Thank you. Yeah, you could Jolly Rancher, that's fine. Alright, so what we call that is a ratio. A ratio. So in other words, if I did 12 divided by 6, wouldn't I get 2? 6 divided by 3 is 2. So when I divide things, that's a ratio. So here's what I'm going to write. I'm going to write times 2 times 2 times 2 times. So you're seeing that. And what I'm going to write down is what I noticed is the y values have the same ratio. And I'm going to box that word ratio. Okay, and then I'm going to also add some words here because do you notice that these points were right in order? -2, -1, 0. They were so I'm going to say consecutive. Do you know what consecutive means? Like in a row. So you can't just divide any old y values. What you have to do is do them in a row. So consecutive y values have the same ratio. Okay, great. Would you now plot the next set of ordered pairs? And if you can, fill in, there's one that I didn't put in there, that's just in the middle. Alright, so what does this look like? Linear. Okay, I'm going to connect these points with a line. Linear. Hey, and did you notice that there was a point missing down here? What point is that? -1, 0. So I'll just add it in when I put it in my table. So here we go. -2, -2, -1, 0, 0, 2, 1, 4, 2, 6. Okay. Let's see if I can figure out something with these. Anything you notice with these y values? Brooklyn? Oh, so these were being multiplied, these are being added. -2 plus 2 is 0, right? 0 plus 2 is, okay. So we said these were linear. And when we found their differences, here's what I mean by differences. Addition and subtraction reverse each other, right? So if I were to go backwards, 6 minus 4 is 2, right? 4 minus 2. So then that tells me, oh, added 2, added 2, added 2, added 2. So this is called slope, actually. Slope. Remember slope? Yeah, so the reason why they're adding 2 each time is that's its slope. Alright, so linear though, what we're going to just realize is that the y values have the same, and I'm going to write first differences. And you might think that's weird that I say first, but in a minute you'll see why I do that. The same first differences. When I subtract them, I got the same value. Alright, so, next. What kind do you think this is going to be? If you had to guess. Let's find out. -211 would be kind of up here. I know it's off the page. -15. Make sure it has curves to it. Okay. What do we call that? Quadratic. And I'm going to do the same thing again. Okay. Let's kind of do what we did last time. First, I'm going to point out to you, if you would start to divide like 11 by 5, that's 2.5. 5 by 3 isn't 2.5. These do not have the same ratio. Here's what I'm going to show you. What is 11 minus 5? Okay. So this is up 6, agreed? What's 5 minus 3? Shoot, these aren't the same. What's 3 minus 5? -2. What's 5 minus 11? Okay. So when I found the first set of differences, they were not the same. But watch what happens on a quadratic. Let's find the differences. I call them the second differences. Here we go. What's 6 minus 2? 4. What's, be careful, 2 minus a -2? 4. 2 minus a -2. What about -2 minus a -6? What do you notice about the second differences? They're the same. So when something is quadratic, the y values have the same second differences.